Hello student, in this video I'm going to discuss about quality management approach or quality assurance in case of system design. How can you provide quality assurance and implementation of your system that you are going to deliver to the user. Total quality management is essential throughout all the systems development steps. According to Evans and Lindsay in 2004, the primary elements of total quality management are meaningful only when occurring in an organizational context that supports a comprehensive quality effort. It is in this context that the elements of customer-focused strategic planning and leadership, continuous improvement, empowerment and teamwork are united to change employees' behavior and ultimately the organization's course. Notice that the concept of quality has broadened over the years to reflect an organization rather than an exclusive production approach. Instead of conceiving the quality as controlling the number of defective products produced, quality is now thought of as an evolutionary process toward perfection that is referred to as total quality management. System analysts must be aware of the factors that are deriving or driving the interest in quality. It is important to realize the increasing commitment of business to total quality management fits extraordinarily well into the overall objectives for systems and analysis and design. One point in this situation is that Six Sigma. The advent of Six Sigma has designed or changed the approach to quality management. System analysts and system users need to be aware of Six Sigma and apply some of the principles to their systems analysis projects. Originally developed by Motorola in 1980, this is Six Sigma. So what is Six Sigma? Six Sigma is more than a methodology. It is a culture built on quality. The goal of Six Sigma is to eliminate all defects. Okay, now the goal of Six Sigma is to eliminate all the defects. This applies to any product, service, processes. In operations management textbook from the 1970s to end of the century, quality control was expressed in terms of three standard deviations from the mean and or 3 sigma. So initially in around 1970, 3 sigmas were there, means three standard deviation from the mean were used, which equal to about 60,000 defects per million opportunities. So 6 sigma implies a goal of no more than 3.4 defects per million opportunities. So Six Sigma is a top-down approach. It requires a CEO to adopt the philosophy of an executive to serve as a project champion. A Six Sigma project leader is called a black belt. The metaphor of the black belt comes from the ranking system of the capabilities in martial arts. So black belt are certified after they have successfully led the project. Other project members are called green belts. Master black belts are black belts who have worked on many projects and are available as a resource to project teams. Six Sigma can be summarized as a methodology. The steps of Six Sigma are shown in the figure 16.2. We'll look into it. Six Sigma, however, is much more than a methodology. It is philosophy and a culture. For more information on Six Sigma and quality management, visit the website for. You can go through this website. In 2002, the Zurich Center issued a proclamation to support and encourage quality. So we'll go to that figure 12.1. So this is the Six Sigma structure. Here you can see what is Six Sigma. Every system analyst should understand the methodology and philosophy of Six Sigma. So first part is that define the problem. Second part is that observe the problem. Third part is that analyze the causes. Fourth is act on the causes. 5. Study the results. 6. Standardize the changes. 7. Draw the conclusion. That is the Six Sigma. So every system analyst should understand the methodology and philosophy of Six Sigma. So there is another method to go through the quality management is the responsibility for total quality management Practically speaking, a large portion of the responsibility of quality of information system rests with system user and management. Two things must happen for TQM to become a reality with system projects. First, the full organizational support of management must exist, which is a departure from merely endorsing the newest management gimmick. Such support means establishing a context for management people to consider seriously how the quality of information systems and the information itself affects their work. So overall, it is the process to take the responsibility of the managers or the leaders to how to maintain the quality of the management. Also, there is another one is structured workflow. One of the strongest quality management action the system analysis team can take is to do structured walkthrough routinely. Structured walkthrough are a way of using peer reviewers to monitor systems programming and overall development, point out problems, and allow the programmers and analysts responsible for that portion of the system to make suitable changes. Structured walkthroughs involves at least 4 people: the person responsible for a part of the system or subsystem being reviewed, second a walkthrough coordinator, third a programmer or analysis peer, and fourth a peer who takes notes about suggestions. So try to understand this part also about structured walkthrough to maintain the quality management of the system. There is another one is topic about quality management is top-down system design development. Many companies first introduce computer systems on the lowest level of the organization. This is where the immediate benefits to computerations are most observable and cost effective. Business often take this approach to system development by going out and acquiring. For example, one example of this software is the COTS for accounting, a different package for production scheduling, and another one for marketing. So when in-house programming is done with a bottom-up approach, it is difficult to interface the subsystem so that they perform smoothly the system. So interface bugs are enormously costly to correct, and many of them are not uncovered until programming is completed because you are going through a bottom-up process. So when analysts are trying to meet a deadline in putting the system together, so that he or she can face the problem. At this juncture, there is a little time, budget, or user patience for debugging the delicate interfaces that has been ignored. Although each small subsystems appear to get the working software what it wants, when the overall system is considered, there are severe limitations to taking a bottom-up approach. One is that there is duplication of effort in processing software and even in entering data. Another is that worthless data are entered into the system, and third is that perhaps the most serious drawback of the bottom-up approach is that while pockets of users needs may have been made, overall organizational objectives are not considered and hence cannot be made. But in case of top-down design, allows the system analyst to ascertain overall organizational objectives first, as well as to ascertain how they are best made in overall system. Then the analyst dives that system into subsystem and their requirements. So that is the importance of top-down system design, and we can see what is the drawback of bottom-up system design. So these are the important things in this case of if you want to maintain the quality of the software design. So try to go through the context again in this book. Try to understand. If you find any difficulty, please let me know. And also if you add something, want to add something, then also let me know. So till then, thank you.